Okay, guys, I think we're live. 4th day of streaming. Let's go. Let's wait a little bit for people to join, and then we can start. So today, going through GPT-NeoX. Let me just share the streaming link on my Discord. Let me find the streaming link. Here it is. Let me just share this with people. Where is my Discord? Do you guys hear me? Let me know in the chat if you can hear me nicely. And today we're gonna start day 4. Sorry for being a bit late. Okay, let's go. Day 4. Let's go through the GPT-NeoX training, fine-tuning, just get some familiarity with the code base, and then we can start building stuff. I think already tomorrow. Let me first share this. Snap! I forgot to change the thumbnail. I'll just update it after the stream is over. Let me just make a to-do. Update the thumbnail. Okay. Let's go. Let's just grab the to-dos from yesterday here. I think I might collapse all of these into a single page. Otherwise, it's hard to organize myself here. So let's just put these here. So let's maybe download some of the Pythia models. That's going to be a first good step, and just see how that works with the generation script from yesterday. I already reached out to Luther AI folks. I'm still chatting with them. I actually got a reply. I got a reply from Luther AI here on the Polyglot channel. They said, I asked, are there any updates for the Polyglot Korean model? The paper mentioned 40 billion plus parameter checkpoints, but I didn't see any updates on that front. Is this being trained as we speak? And what's the future roadmap for the Polyglot project? And then they said, for Polyglot KO, we are currently trying to procure processing resources that is permissive in both compute bandwidth and storage to process 3 terabyte of Unicode Korean data for deduplication, and then M mapping for GPT-NeoX. We had a difficult time due to current restrictions, but thankfully it seems that the project lead, Kevin KO, managed to procure some resources. As soon as the credentials come through, we will proceed. How many terabytes of RAM do you think you need for the full 3 terabytes of data? I don't think we have finalized which tools to use, but if we use text deduplication, it can be scalable by setting shard size. mmap for GPT-NeoX, I have little experience with. Okay. That's some update there on that front. Let me see what else here. Okay. So I think as soon as we are done with GPT-NeoX analysis, we can start slowly building. We can start from the small checkpoint, 600 million, start getting some people on board here, and we can collaborate together. These couple of first days were just explorative in nature, so that was kind of the idea. Okay. Without rambling anymore, let's just go and find Pythia, Luther AI, and let's see the checkpoints here. Okay, here are checkpoints. I can see the Pythia 700M. Let me just compare which configs they have in the NeoX. Let me just open VS Code. Okay, so here we are. Just a second, let me set up the stream so that I can see your chat messages. Okay. So, configs are here. So here are some of the checkpoint sizes. Now let's compare that with Pythia table here. And can we actually reuse some of them? 70M. It can be, by the way, that the size is reported here and the size is reported here are measured differently. So for example, I'm not sure whether they're using the embedding, whether the embedding table is being counted in. So we can maybe just compare the number of layers. Let's see whether some of these checkpoints are comparable. If we open up the 350M, that's 24 layers. Okay, and if we open up some smaller checkpoint like 125, that's gonna be what, 12 layers. 7, 6, 8, 12 heads. Okay, I think this one corresponds to Pythia 160M. Let's try it. Let me download the Pythia. Let's download this. Okay. Apache 2. Non-embedding. Let's download this one. Training procedure, eval, changelog. Can I just manually download the checkpoint, or how does this work on Hugging Face? I usually just run the snippet and then it automatically downloads. But if I need to download, do we have to do some conversion probably? Yeah, there is a binary here. Has anyone done something like this before? Basically downloading Hugging Face checkpoint and then running it in GPT-NeoX. I doubt any such person is currently in the stream. I'm not sure it's gonna work out of the box if we just download using Hugging Face. Let's see. Save tensors, we don't care about that. Let's quickly go here to GPT-NeoX, see the issues, see whether Hugging Face is mentioned, and then find convert Hugging Face Llama to NeoX. That might be useful to us. Cannot load the checkpoint. Let's see those two. Okay, this is not relevant. However, the script to convert Llama weights to NeoX only support original Llama weights. Issues installing, bear with me please. Any plans on supporting modeling? Question, reconstructing. Okay. Is there Hugging Face mentioned here? I think they that's the thing, like it's not, they didn't envision this repo to run inference in. That's why they mostly offload that to Hugging Face. I think because we'll just be exploring the repo, I don't think we need to obsess too much with actually having a valid checkpoint locally. Because of that, let's just see how we can run some of the other like training or fine-tuning or eval or something like that, just to get some familiarity. So maybe we can we ran prepare data yesterday. That's where we stopped last night. Actually, I'm lying. We ran the pre-processing data, pre-processing script in the tools. So this one, let me just find it, tools, pre-process data. This was a script that we ran last night, and then it took some time because we downloaded this NVK8 dataset by default, and then it downloaded it, and then then some processing was performed here. And I think we finally have the output results here in data and Wiki, and then you can see here we have the two tokenized files here, the bin and the IDX. Okay. Let me just see whether I actually understood what happened here. I think they just created this mmap dataset. Let me rerun this. Maybe we can skip the part with tokenization that was super slow. Let's see whether we can rerun this quickly. Let me maybe rename this so that we don't lose the file. I'm gonna add suffix old here, suffix old, and then we can rerun the whole thing from scratch. Pre-process data, that's the right config. Let's kick it off. Here we are. Let's just build all of this. We don't care here. Initialize, create a generator. We've been through all of this last night. So make builder. Will we actually enter here? Yeah, we will. Okay, so we create this index dataset builder. Best fitting type, because it's 50,000, maybe in 16. Yeah, so we're gonna end up with in 16 here, unsigned integer 16. And then they just open up that file for writing, and then the whole logic happens later on outside of the init. Let's go. So this is where the processing will start. Basically, we'll end up calling the yield from files, and we'll end up calling the encode method of the encoder. So if we go here, and if we now just run this, so we end up here, we acquire the semaphore, and then we start the encoding. So now this tokenization is going to take a while. Let me just see. Yeah, the tokenize method here. Let us let it run while we are doing some other stuff. So that's gonna be running in the background, and then later we can step through the pre-process data script. Until then, let's go and play with different parts of the code base. Okay, what else? So we ran dpy is the entry script. We ran the generate. We are left with evaluate. We ran this one as well and train. Let's maybe immediately start with training. Let's see what we need to set up to call a training run. If we go to the README, I'm going to open up the readable version and then search for dpy train. So there is a couple of lines here. This is how we launch the training. Launches the same script in parallel across many GPUs/nodes. Okay, so we need to pass a couple of configs. Okay, so I think we can just run this. Okay, we should be able to just add this. Let's now find the launch JSON. VS Code, launch JSON. And then we can create a new config and just pass in these arguments here. Train.py, configs remains the same, this remains the same, everything remains the same. We just delete this and then we rename this to train. Okay. Here we can now go to dpy script and we can run it. We'll have to create another Python process because this one is already running. Let's just kick it off. Yes. Let's see whether this works. Okay. Okay, there is something is wrong here. I messed up somewhere in the launch JSON. Let's see what. Train py d configs local setup YAML. I don't see an issue here. If anybody sees a problem, let me know. I don't see an issue. It looks the same as above. We don't have to, maybe we have to pass something like text generation. Let's see among configs whether there is something that sounds like we need to pass it as additional config. I don't see BNB, BF16, various checkpoint sizes, Pythia. Okay, Pythia actually has its own configs. Okay, that's what we would use if we were to actually download the checkpoint. Llama, fine-tuning configs, auto-tuning configs. Nothing here seems like... And in the README also they don't mention. Let's see. README. Train.py. So that's all. We should just be able to pass in Python dpy train configs local setup. That's it. And if we go here, we have the same thing, right? train tconfigs 125M YAML local setup. Oh, maybe because I did modify this guy, maybe there's some issues now with, maybe we need to retrieve this back to 1, and now there are no changes. Let's try and rerun it. I'm not sure whether this is going to work. We're going to try. Okay. Let's go back to DeepSpeed script and then let's rerun it. Yes, start a new process. Let's kick it off. So there's some issue here. And I don't see, I hate, okay. Oh, okay. I see that I'm constantly focusing too much on the red message and I'm ignoring this one here. So it says unrecognized arguments. What's the unrecognized argument? We probably, okay, let me just go to the local setup. Data path, we probably have to set some of these. Let me see. I think this is just the only thing. So data and Wiki 8. Okay, got it. I think we need to do the following. Let's just change this to add the old long JSON configs local setup. Let's add the suffix old. This should now be good because data has NVIC8 text document old as a prefix. Let's see whether this works or not. I think we didn't even start a right program. We started pre-process data again. Let's just find, this is kind of annoying. Let me move this to the side somewhere. Let's close this. DeepSpeed, okay, let's run this. And we also have wrong config. Okay, that was the issue. So now it should work. Let's go. Consume, everything is working now, awesome. DeepSpeed, 1 dB, and we can now go here and let's just add a breakpoint in the train script, which we already did, so we can just hit F5 from the DeepSpeed script. F5, we should hopefully hit the breakpoint in the train.py, and then we can take it away from there. Let's see. Consume, configure distributed arguments, build the tokenizer. We just built GPT-2 tokenizer, vocab size with padding, all of that is good. Initialize the, and now we enter pre-train. So main training program, this function will run the following in the order provided. Initialize Megatron, set up the model optimizer and learning rate schedule, call train val test data provider to get train val and test datasets and train the model. Okay, So first, a bunch of setups, distributed setup, model optimizer learning rate, data sets. Hi there, good to see you as well, Pixel. Welcome to the stream. We're just iterating through the GPT-NeoX code base. In particular, we're going through the training pipeline. So we can initialize the Megatron logic. Okay, I think that failed. Or did it? Let's see. Let's see whether this run is gonna crash or not if we just kick it off as it is. Okay, I see something going on. Training. Optimizer step. Okay, we're actually running it. Here it is. It's running in the background. So next step, we're gonna again understand how exactly what's going on here. Optimizer. We can set up weights and biases to track the curves in a browser dashboard. Let me see what's the config, how many... Okay, I think we can stop this for now. Let's just stop the training run. Let's just stop it. Let's first step through the pre-processed data. Let's end that because we were waiting in the background for the tokenization to end. And now we have a ton of tokens here, as you can see, 29 million tokens from tokenizing the whole NVK8 dataset. Let's see what happens now. Encoder get. Okay, so we're now getting just the IDs, and then we can hit F5 to just fill in the IDs here, and then we retrieve back the IDs. So that's going to be the logic happening here. This should be fairly fast because we're just getting from a dictionary, so that's kind of one operation. We have 30 million iterations of this loop. I'm expecting this to end up fairly quickly. One thing we could do to estimate the progress is maybe just add a breakpoint quickly and just add, let's see where this will work. Index of token. Okay, this is actually fairly slow. Let me just run this again. And then let's put a breakpoint again. Okay, this is not working correctly. It probably just is fetching the first, token it finds. That's why we went from 933 to 593. This is definitely not. I'm trying. Okay, here it is. IDs. So we've done the tokenization. We are done there. Now we have the text IDs. And then we just append those there. And then we just additionally append. Okay. Let me see how this looks like. IDs of key, doc IDs. Looking good. And byte processed, we release the semaphore, we go through the sentences, for each of the sentence, we create a NumPy array here, we grab the D type, which is going to be unsigned integer if I recall correctly, 16, yes, and then we just add the item. Let me just see what happens if we enter the add item. If we enter the add item, what happens? Okay, we are in the mmap dataset. Assert is instance. Okay, and then we write inside into this file. We just convert the numpy array to bytes, and we write that to the file, and then we just append the sizes. That's it, and we are done. And then we call the end document, which is gonna do what? It appends this. Okay, and we're done there. And now we just log the progress. And we're done. That's it. So we've successfully written to... So the part that confuses me is probably in the finalization here. We skipped this one. Let me just quickly find the make builder, this guy, finalize. We close the file and then we write to the index file. Got it. I didn't see where we created the bin and the IDX. That's the part that I kind of missed. Okay, interesting. Okay, this is from the training run, I guess. This is just from the training run. I'm going to delete this. And let's kick it off again. Let's go to train. We can ignore the preprocess script now. So let's go to the DeepI. Let's rerun this. Pick the train, run. Okay, and let's go to, let's just hit F5. We should end in the train script. Wait, I'm forgetting to add a breakpoint here. Wait. Stop that. That was a mistake. Again, let me just delete this quickly. Again, train. We have a breakpoint. Now we can actually run it. Okay. Let's wait until it hits this breakpoint. Now let's go step by step. Okay. We initialize the Megatron. We can ignore the logic there. And then some timers, set up the model and the optimizer. Okay. That might be fun. I think we've seen that last night as well. Yes. Let's continue here. By the way, we have two processes. That's why we are repeating some of the same code paths. And then build, train, valid, test data iterators. Given the arguments, we're going to build these. I haven't gone through this, so let's step through this. Print. We grab, is the first stage true? Is it the last stage true? Because we have a single pipe. i.e. we don't have pipeline parallelism, which is just equal to 1. And then pipe load true. Let's just see what happens here. Train iterations. Okay, 320,000 iterations. And for eval, we have 100x less, I guess. And test 10. Okay. Number of samples. If train data paths. So wait, what did we exactly set here? If we go to configs local setup YAML, we have data path here. And these are some other arguments. Valid. This is if you want to do weighting, which we don't want to necessarily do right now. Okay, let's go back here. Build the data sets. Here is the data path. Use shared. Let's just see once we start creating those files here. Split. Here is the split. What's shared FS? Shared file system? And map. All of that looks good. Sequence length 2048 context length. And skip warmup true. And then we just create an indexed data set, which is going to go to mmap, and we return this guy. Okay, this logic is actually pretty much the same as what I've seen in FairSec as well. The same logic, I've seen it in FairSec. It's just your implementation of mmap. Total number of documents. Generate the splits. What does this do? Split index. Okay. Print the stat. Building train, blah, blah, blah. Reading. Okay, this is just the number of documents. We just have the train document, I assume. Okay, let's build the train, let's build the validation, and then finally the test. Okay, arrange, and then GPT-2 dataset with name train, data prefix, documents, index, dataset, sequence length, blah, blah, blah. Let's go here. Build index mapping. Okay. Let's just roughly see what's going on here. Build index mappings. Data prefix, documents, sizes, number of samples, sequence length. Let's go here. That's the size, that's the number of tokens. And documents. Okay. Tokens per epoch, that's the whole data set. And then number of epochs, 181, because what? Because we have That's the sequence length, that's the number of samples. How does this computation exactly work? Got it. Random state. We can skip all of this. Could not find the map files building the indices. Now we start building here. Number of epochs. And then we save it. I guess that's gonna save the file here. Yes. So this is the thing we just got. Print rank 0. Number of samples. Let's just continue going over this code. Build shuffle by index. We save that as well. Okay. By the way, guys, do you hear the noise in the background? Because my girlfriend has a meeting. It's kind of hard to, we don't have, didn't close the door, so I can go and close the door if you hear a lot of noise. Okay, and now this kicked off yet another, this is super annoying. Let me just go to the separate thread. Hi Luca, welcome. Welcome to the stream, guys. We're just iterating over the GPT-NeoX codebase. Let me just see what's going on here. Build and train. Build the index mapping. You can exit here. Hi Smith, welcome to the stream, man. And then we build. Oh my god, my voice is dying. Build data set. We do the same thing here. And then here as well. So these two are none because we only specify train. And this is a GPT-2 dataset. Okay, and then we just do the same thing for validation and ditching work for some time. What do you mean by that? You mean this is your guilty pleasure, watching me stream? Flags. Broadcast. Okay. We just wrap it into an iterator and we return back all of those. Okay, that's it. We are back in the pre-train in the high level. Okay, thanks, Abhijit. Hopefully I'm not butchering your name, Abhijit. Okay. Iteration 0. Train. Okay, so here is where the magic happens, right? This is the validation, which we will not do because it's 0, and then we'll be saving checkpoints. Let me put the breakpoint there, and then test is also probably, we won't be doing tests. So that means we want to see how the checkpoint saving looks like, and then we want to see a bit about how the training loop is set up. So let's kind of go in there. Guys, let me go grab some water. I'll be back in a minute. Be right back in a minute. Otherwise my throat will die. Just need to pour some water here. Nice. I'm back, guys. Okay. Let's continue. Let's hit F5. So we set the model to the training mode. Iteration 0. Get the noise scale logger. Overflow monitor. If we've skipped many iterations in a row, and trigger an early exit. Okay, we have 320,000 iterations. This is the 0th one. There is a train step here. Let's kind of see the high level structure here. There's a train step, then some incremental stuff, incrementing the counters. If precision FP16, then we checked for skipped iteration. Get learning rate, training log, checkpointing, evaluation, every 1,000 iterations. But we will not be doing this because validation is set to false, so we can collapse this. And then finally, exit interval is none, so we won't be doing this. Distributed barrier, this is, I guess, for when we are running on multiple GPUs. We are currently running just on a single GPU, even though I have 2 in my system. I think model parallelism and pipeline parallelism are both set to 1. I'm not sure about data parallelism. Where do you set data parallelism? Let me just see here in the config. If we go back to YAML, there is the parallel stuff here, but there is no mention of the data parallelism. Data, maybe in the local setup. Nope. Anyhow, let's go back to the code. Train step, that's where the magic happens. F5. Train step pipe. Let's go inside here. Train batch, and then we pass a data iterator. So this is where everything happens. A lot of abstraction. We just keep on entering, putting new stuff on the stack. We're just going deeply into the code base. Train batch. Let me see what the comment says here. Sounds good. Set the data iterator. I'm not sure what this does. Let's see quickly. Okay, just internal, sets internal member variable. Timer sets to true, scheduler, microbatch 1, number of stages 1, stage ID 0. Execute the schedule. Is that where the main logic happens, I assume? Loss here. Aggregate total loss. I think, yeah, this is where execute schedule is where the main happens. Train schedule. This is where everything happens. Let's enter. Reserve pipe buffers. And then for command load microbatch, so it's basically dispatching tasks. That's how the framework is set up. You're dispatching some tasks like load microbatch. Okay, and then some error checking, and then the type of command instruction map. What's the type of the command? Load microbatch, and then load microbatch maps to what? Let's see what this will give us. Curious. Pipeline engine execute load microbatch, add some address. Okay, method type. And then we basically run this. Okay. Some timer stuff. Next batch. We grab a batch of data. Here is a tensor, which if we just extract the, let me just extract the text key. Let's see what's the shape of this guy. So basically 4, 20, 49. Why 49? Why not 48? And why 4? Is the batch size set to 4 somewhere here? Let's check out the microbatch size per GPU. I guess that's where 4 comes from. Batch and data settings is 4. That's the reason behind 4. I'm not sure why we have 2049. Why not 48? Probably some, I don't know. That's weird. Let's go. Batching function. Post-processing, like broadcasting across a slice parallel group. Let's see what this does. Get the batch pipe. And then broadcast data. Labels. And tokens. Oh, okay, yeah. It's 49 because we still didn't create the actual output that we'll be comparing against. So now after this code is run, we have 2048 as expected. Okay. Get the masks and position IDs. We can skip this function, all good there, and then we return back all of this, and we can safely return the data. So that now has the, as you can see, is this a dictionary or like a list or what? type of batch, it's a tuple. And then if we just fetch the 0th element and we print the shape, or what's the type of batch of 0? Again, tuple. What's the length? Is this 2? 3. So let's see what happens if we print 0. We get some shape. Okay, expected. Why do we have 3? 1, 1, 20, 48, 20, 48. Interesting. And then if we do batch of 1, what's here? What do we get here? Okay, let's see what's up there. Okay, let's continue. If we are in the, so again, we are back to the execute load microbatch. Interesting design of the library, honestly. Oh, okay, we are inside of DeepSpeed. That's the thing. This is actually DeepSpeed logic. As you can see here, side packages DeepSpeed. For X in batch 0. Clone, detach, put to the device. Append. Append. Okay. And if it's the last stage, loaded. Set timers. Interesting. Okay. And then the second command is Oropas. Okay, got it. So all of this is just DeepSpeed logic. I've actually played with DeepSpeed before, so that's why it looks familiar. Train batch. All of this is delegated to the DeepSpeed from GPT-NeoX. Where GPT-NeoX stops is right here. Train step pipe. And train step. So this is where it stops. Okay. Let's execute this quickly. Inputs. Where is the terminal, by the way? Let me just... Okay, 0 grads, inputs. So this is the inputs are from the previous iteration of the loop where we done the microbatch loading stuff. And here is the forward pass with the inputs. And the inputs are, as far as I can tell, the first element of this tuple is, I see the positional indices, and then the 0th is the actual data. And then the second element looks like some, is that like a attention map? Attention mask? Let's see this. Yes, it looks like it's just an attention map. Maybe we can quickly plot it and make sure. Let me do one thing. So this is a tensor. Let's push it to a CPU and convert to NumPy. And then temporary is going to be just type of TMP is a NumPy. And let's now save NumPy quickly. numpy save. What's the how do we call that? File array. Okay. Let's run something like that. So numpy, test numpy, and then let's just save it. Let's just save to that file. Let's save the TMP variable. And let's see where that's going to be saved, probably in the root. Okay, we have to import numpy as np. What is the problem here? Okay. Here is the test numpy. Now we can quickly open up playground py. Copilot helped so tremendously. And then plot the data. Let's see if we do this. Will we get anything meaningful if I do this? Let me quickly see this. Whoops. Just a second. Okay, we don't have numpy matplotlib installed. Let me quickly install matplotlib. So conda activate GPT-NeoX. Install matplotlib. Okay, let's now rerun this. Why are you constantly... Okay. Plot. Okay, yeah. We have to extract... We have to extract the data. Let's just extract the 0, 0. Will that work? Yep. Okay, there was some pop-up that I don't see anymore. Why does this look so weird? Wait, just a second. Did I mess something up? If we grab test of 0, first 10 elements, everything, okay, false, true, 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 and then false, false, true, true, true. Okay, this is definitely the causal mask I was expecting. Okay. Why is it not printing nicely? It doesn't matter. I can see that it's a causal mask already down there. Let's end this And let's go back to the execution here. So we are in the forward pass. Okay, we actually already stepped over the forward pass there. We got the outputs, which are just probably logits. Okay, yes, for batch size 2080, 2048 and 50,304, which is the vocab size. We skip this, and now we just store. Okay, labels. Here are the labels, and then we just do the loss function, which is just cross entropy stuff. Parallel cross entropy MPU. This is interesting. We go from here, we go to GPT-NeoX. Interesting. And then we call MPU. Okay. Append the loss. Detach. Okay. And then backward pass is the final component. So this is how this is structured, right? There is the load of the microbatch in DeepSpeed, then there is the forward pass task, and then finally there is the backward pass task. And the backward pass does what? Some assertions, memory status. What does this do? Nothing. Okay. We call the backward, and then we return. And that's it. So now we have what? Reduce tide grads. What does this do? Let's enter. We need to run this first to write to self-averaged gradients. Since this class turns enable backward all reduce off. This never actually runs. I suspect this is because of efficiency problems. Let's quickly see what this issue is about. Curious. Okay, this is back in the early days of Eleutheri, Stella, and Leo God. This guy was a co-founder of Eleutheri and is now working at OpenAI. Get tide weights and groups. What do they mean by tide? Is it like tide as in input and output embedding table tide, or what? Do we get anything here? It's empty because I think. Let's go back to the config here. 125M. I think I've seen, just a second. Let's go to launch. We are using 125M, right? Yes. Pretrain 125M. If we go to some bigger model, let's see here. Okay, it doesn't matter. Okay. Reduce gradients. All of this is inside of DeepSpeed. So all of the core logic happens in DeepSpeed. Bucket size. Okay, and then optimizer step. Interesting setup. Interesting design of DeepSpeed. Take model step with learning rate. Optimizer all gather. Optimizer gradients, optimizer step. Okay, and finally, that's it. That was a couple of steps, and now we are done with the first. With the first forward pass and backward pass. First step of the iteration of the training loop. Scale loss by gas. What's gas? Gradient accumulation steps or gas. Nothing will happen there, that's one, which means we just end up with the same loss, 11 point something, no. Loss 11.0018. Okay, average loss. If is data parallel, which is true, then we do all reduce. Am I running this on both GPUs? Okay, it looks like we are. I see 9 gigabytes here, 6 gigabytes here. I'm curious what happens if we, how much, what's the biggest model we can run using GPT-NeoX on my machine. Let's test this next. Let's see, just get a feeling for the scale we can do on my local machine. All reduce, blah, blah, blah. Okay, my VS Code is glitching. Slow for some reason. Let's see what's going on. I see it's running here. Next up, we can try 350 million. I think we should be able to squeeze in that one. Probably around, this one will not be able to run already 760 million. We can't run training for that, probably. Okay, why is this so slow? Guys, VS Code is terrible on Ubuntu. It's so slow. I'm just trying to run this, but it's not going anywhere. Okay, let's see. Come on. Even the GUI is not really responsive. Like I'm. We've seen the main part though. Execute schedule is the main logic. And then everything else is, let's maybe see the logging of the loss. Let's see whether we are actually training this on this NVIDIA dataset. It was actually fairly easy to set everything up, right? We've set up the environment, then I've tokenized it and downloaded the Wikipedia dump, and now we're already running a training on 125 million checkpoint. Okay, this is not working. Let me just, I'm gonna kill this. Let me kill the VS Code. Let me disable all of the breakpoints except for this one. And then let's go to DeepSpeed, to the entry script. Let's rerun it and get back to the same state. Okay, here we are. We scale the loss, all reduce. Okay, that was actually the issue. The issue was I was trying to run all reduce, but I had two processes and the other one was up there on this line, and so that's why it was stuck. It was basically blocked. Now it's working. It was actually my mistake. It was just not intuitive, so I didn't know. Okay, let's exit from here. Train batch stopped. We are back here. Loss. Let's go back. Okay, here we are. Logging. And then we're gonna skip this as well. And we just keep on iterating. So that was it. That was actually not that hard. Let me see, why are we not printing the loss anywhere? It would be cool to just set up either weights and biases or console logging so that we can see and track the loss, how it looks like. Let me let it run a little bit and see what's going on. Let me just remove all of the breakpoints, disable all breakpoints, and let's run. Let me just see the outputs here. Every now and then it's logging something a bit different. So every 50 steps, it's in what? Okay, I see the loss here. 8. And then here 9. And then here 9.3, 9.6. Okay, so we're definitely, the loss is getting lower and lower. Surprise, surprise. Let's just see how that goes. But it would be cool if we had either a tensor board or weights and biases to track it. It doesn't matter at this point that much. I was more curious to understand just how the framework is set up, how that whole boundary with DeepSpeed and Megatron looks like. You can barely see the loss in the console. I kind of have to stop. Okay, it's going down. It's definitely going down. Okay, we can stop this because we're not trying to train this model right now. Let's just stop this. Stop this as well. And let's try and rerun it with a bit bigger checkpoint. Okay, let's go to train. Let's try the 175 first. No, sorry, that's the 175 billion. Okay, my mistake. $350. Let's try this one. So, training. Let's find the train script. Let's go here. Let's call the dpi again. And let's see what happens. Okay, so you can see here 2 gigabytes to start with, almost 0 megabytes on the other GPU. And let's now run and load the models. Let's initialize all of these. Okay. Did it load already there? Okay, C6. Let's just let it run. Let's just hit F5 there. Okay, so we are training. Clear. Okay, around 10 gigabytes. I think we can go even higher, obviously. Let's try that. So that was the... And especially if we do model parallelism, we can squeeze in more, but the training would be super slow because we don't have data parallelism. Okay, 350M, let's try 760M. This should be close to the amount of VRAM I have available, right? Let's see what else do we have here after 750. There, 760, there is the 800. Let's run this one. Let's kick it off. Okay, we are running. $14 and 17 megabytes. Sorry, gigabytes. That's impressive. Let's push it even further. We have 800 and we have, what's the next one with the billions? 1.3 billion. Can we actually squeeze in 1.3 billion to train here? Let me see what's the setup here when it comes to, okay, model and parallel, 5 parallel, 1, 1. This guy is also 1, 1. Let's run 800 and then we have the 1.3 billion. $800M. Let's go to DPy. Let's run this. Just trying to understand how much we can squeeze in. Okay. So here we are hitting the CUDA out of memory exceptions. I did expect to get to some range like this. I did not expect us to be able to run 1.3, but if we go here and if we change, let's just stop all of this. Stop. Okay, and then go to 800M and let's try, if we just do this, if we set the model parallel to 2, what happens now? We should be able to run it now in expectation, right? Okay, looks like we're running, guys. It's running. Let's see the VRAM consumption. Okay, 18 and 16. So this is the best we can do probably on my system. We can train 800 million. If we were to optimize, we could probably squeeze in. There's a bunch of things we could do, like offload to CPU. There is a ton of optimizations we could do, but it would be super slow. So with 1.3B, we would probably already be way out of my memory limit. $20B, 1.3. Let's see the 1.3B. So let's stop this. Let's stop the training. Let's put 2 here. And let's try and set 1.3B here. No, this is generation, sorry. We're gonna change this one. And let's kick off the run. 1.3b. dpi. Run the training. I don't expect this will run without a crash and CUDA out of memory. Maybe, who knows? Oh my god, it's actually running. But this should be super close to the limit, right? Or something is not right here. Okay, 20 gigabytes and 17 gigabytes. We can actually run 1.3 billion on my system if we use model parallelism equal to. Nice. Now it will probably take a ton of time to get to anything. Maybe as an interesting experiment. What I want to do, obviously it's gonna heavily overfit on this small data set I'm currently using. But it will be a fun experiment to set up the weights and biases and just track and overfit, completely memorize this experiment just to see whether we encounter any issues or whatsoever, just to test the GPT-NeoX. Okay, so let's do that. Let's see what we need to do to get weights and biases to work. So first of all, let me double check some settings here. Okay, so this was the weight tying I was mentioning. I think this is just controlling the input-output embeddings. This is for the fused kernels. Atom. We are using DeepSpeed 0 optimization 0.1, so stage 1. So I guess that's why we can run 1.3 billion. We can obviously always reduce the batch size as well. FP16. Is anyone actually training in smaller precision than FP16, like FP8 or Int8? Okay. Let's see how we can set up weights and biases. I would love to track. I would really love to have a 1.3 billion model overfit on my Wikipedia 100 megabyte data set and see how that looks like. That would be fun. So let's do the following. Let me see weights and biases when DB. Extract the API key and inject into work. I'll probably have to just on my other screen fetch my weights and biases API key and then set it somewhere here. What's the netrc file? Probably just fetching it somehow via some internet protocol, no idea. You don't have to locally store it, you just give it authorize access to your dashboard or something, I don't know. If that makes sense. Could we just set up something like n file Okay, guys, obviously I'll have to do this on the different screen. Let me just see. Let me see whether they have any instructions. What does bork mean? Our current VenDB logging assumes the presence of an API key, which you don't need if you're running it locally. We should configure it so it works with VenDB locally as well. Close this as completed. Okay, there is a local support as well, but we can just use. I'm not sure how to run it locally. Your own charts. Okay. I definitely want to have that data in my weights and biases console. So what I'm going to do is weights and biases. Let me just log in there. Let me just sign in here. Just a second, so I'll be signing in to weights and biases. And then let me fetch the API key, profile, blah, blah, blah. Where is the key? API key, get weights and biases, API key. Let me see. Here is the documentation, quick start. Where do I find the API key? Provide your API key when prompted. Okay, I see the key. I'll need to store that somewhere locally. So let's see how can we do that. So VenDB API key. If I just store it here in the env, will it actually work? If I just do something like this, create an env file, and then do this, will that work? Let's try blah blah. Let's see where it will actually load that when we kick off the the script here. Let's see. Just a quick test. Okay, let's enter here. So let me just dump this. Is this present now? It is. Okay, interesting. Interesting. It should work. Blah, blah. Awesome, awesome, awesome. So it's smart enough that it knows to pick up the variables there. Okay, so this should now work. So I'm gonna now go and paste my N file. Obviously, I will not be able to show you this. So let me just go and wrap that up. Okay. And now if we run, will this work? Let me just out of precaution, run this. Okay, let's start running. F5. So again, we're using launch.json. We're using the 1.3 billion model checkpoint with model parallelism set to 2. Pipeline set to 1, data parallelism obviously set to 1 because I only have 2 GPUs. So let's see whether this is actually logging to my dashboard. Projects. I don't see anything happening. Are there any runs? Okay, nice guys. Look at this. Let me show you this. Please zoom. Please maximize the window. Please, please, please. My system is glitching on Ubuntu for some reason. I'm not sure what's causing these slowdowns. I'm constantly getting some report error on Ubuntu. Something's not okay with the system. So here is the run we are currently running. So it's running state. It's on Ubuntu. That's my current machine. And let's see what's going on here. Looking good. Where I can actually see the charts. Good morning, SQ. I didn't see your message if you wrote it recently. Welcome to the stream. Monday. Let me see whether there are some charts below here. Attention loss. Is there a loss being logged? What exactly are we logging? Let's see that. No, these are just the configs. Where are my charts? I mean, if one thing they're logging, I would assume they're logging loss. By the way, I can feel my GPU is getting heated up. All of a sudden, I feel the heat. Let's see the temperature. Probably around 65 or something, 70. So you can see the temperature 73 and 75 here. Fairly intensive. Let's see the consumption around 20 gigabytes and 17 here. It's just eating it. Okay, guys, I'm gonna do a quick break. Gotta jump to the toilet, and then I'll be back in a couple of minutes. Let me just write that in the chat somewhere in case new people join, so that you know. No heater needed. Good winter. 100%, man. It's just that it's currently summer where I'm in, so, and it's fairly hot. It was like 35 degrees outside over the last couple of days. Be right back. Mini 3-minute or 5-minute break. 5-minute break. Let me just quickly Do you guys hear me? Just let me know if you can hear my sound. I'm back. What did I miss? How is the party going? Okay, let's see. Anybody has experience with weights and biases? I did play a bit before, but like I haven't played in a while, so I forgot some of the basics. But just a second. Sorry guys, let me just move this here and. Why is this so slow? Everything is slow on Ubuntu. People are hating on Windows, but there are so many tremendously good sides to Windows. I'm trying to find where are the loss charts. I would assume that GPT-NeoX is logging loss somewhere, and I'm just trying to find that chart, but I don't see it in my dashboard. And let me just try and zoom in here. Can you do a recap on what you have done so far? So this morning we went through GPT-NeoX. Basically, we quickly skimmed through the pre-processing data script from last night, and then we stepped through the training script, and then we tried and ran multiple checkpoints until we maxed out the VRAM. We are currently running a 1.3 billion parameter model on my 2 GPUs using model parallelism equal to. And we are now, I also added support for weights and biases logging, and currently trying to just see the plots and see the loss go down. Basically, I'm expecting to overfit on this particular data set, so I just want to see the curves reflecting that hypothesis. That's kind of the TLDR, Salvador. Why do you need GPT-NeoX to replicate NLLB? Because I'm thinking of potentially running all of these future model trainings in GPT-NeoX. We would have to implement some stuff, but I think it's a good framework. The thing with NLLB in FairSec is that it's like a 1-year-old branch, and so if we hit any issues, that might be a fun experience, right? Like we will have to debug a bunch of. I have a feeling that we'll hit many more issues than if we were to just take some time, implement everything we need in GPT-NeoX potentially, and then start training there. If that makes sense, let me know if you have any insights I'm unaware of. Let me just see where do they call the VanDB init, and then let's see where do they log VanDB log, and then we should be able to see the charts. Okay, let's go here. And then let's go to the logs. Here are the logs. So we can see the loss is going down. It would be nicer to see this on a chart. So the final result will be a decoder-only model, but for translation. Does GPT-NeoX support any encoder decoder? Like I'm fairly sure we will need encoders as well. Okay, so we see the logs. I don't see the, just a second. So there should be some charts which we don't see. Why don't we see this particular tab? Files, runs. Okay. Workspace. Okay, here it is. Under workspace, runtime. Okay, here it is. Here are some curves I would. Okay, we can see the, guys, we can see the loss going down. There are no spikes. Loss scale is not changing. Learning rate is going up because we are basically warming up still, I would assume. And then let's see the system, because my system is for some reason very slow. I'm not sure what's going on. Let's see whether there are any insights here. Allocated bytes, memory, power usage, around 100 watts. No, 300 watts. We're pulling in a lot of power per GPU. GPU temperature stabilizing around 70. Utilization 100%. What's up with that? Okay. So that's pretty much it. I think that's everything we are logging is up there. LM loss scale, and learning rate. Nice. How could we estimate how long will this run last? Let me just refresh this page. $20 minutes so far. It was so easy to set it up. Just grab an API key and start running. That's why weights and biases is in such a nice package. Everybody's using it. Let's just quickly just curious to see where they are initializing this. And then they grab the VenDB project name. Here is the logging key value. Timers. So what we care about is this function. That's in the evaluate script. We don't care about it. We care about this. So we are logging here total loss dictionary. Loss scale, train, learning rate, timers. Okay, and all of this is inside of training log function. Logging is here. Okay. So this is where all of the magic happens. After we've done the training step, a bit later we call training log, which in return calls some of those wrapper functions around weights and biases. And that's how we end up logging the everything we need. Let's check the loss again. And I'm going to leave this to run for some time just to see what happens there. And we can continue. Have you collected the data? Not yet. We do have some data available. There are some public data sets we can reuse. And there is also the laser repo that we analyzed over the last couple of days that we can use to mine parallel data. How did laser work correctly? Well, I did film all of that. It's many hours, so it's kind of hard for you to go through it, obviously, but you can check out some of the papers. Basically, you embed the monolingual corpus in one language and then in the other language, and because the embedding spaces are aligned, you can basically find parallel sentences by just finding nearby points in the embedding space to your particular source point. So if your source point is like here, and then you have a couple of points from the target language around your point, you just find the closest neighbors, basically. And then there's some additional margin logic. How do you actually pick the best candidate? If that makes sense. Okay, just a second, let me open up the Notion. My whole system is glitching, by the way, so it's like hard to type. I'll see what's going on there a bit later. So this is done. Okay. Let me just think what I wanted to do here. Let's see whether there is anything else interesting in the GPT-NeoX, and I think we can slowly start thinking about collecting data. I think I will have to do some calls probably today just to off the stream to see what's the best way to proceed, because I want to start engaging some people who've done similar things already and just consult with them. Obviously, it will be hard to film the meetings on the stream. I might have to end the stream a bit earlier because of that, but let's see. Okay. We ran the train script, prepare data, generate. Let's see the eval. Potentially. It's up plan. I'm not saying it's the plan. We'll see. We'll see what makes the most sense. I've never trained any model in these frameworks, so like trying to get some information and hear it from people who've done it already. Are you curious in joining and contributing? I'm going to create a fork soon and then start working on this. Awesome. Do you have any experience training larger scale systems already? There is no public repo for it already, but I'm going to create one very soon, probably today or tomorrow morning. You're more interested in the mixture of experts version. Okay, makes sense. That makes sense. But like, I think that mixture of experts does not make that much sense unless, like, I think we should train dense checkpoints for closely related languages in the same language group, like Slavic or like Germanic or like Chinese or something like that. And have a couple of those dense checkpoints and then push above the 3.3 billion parameter threshold. That's how I'm thinking about this. Okay, let's just quickly skim through this. Lost logits. Did you guys ever use Parsec or GPT-NeoX? Or did you train any larger scale models? Any of you? Let me know in the chat. Nice. Are you training that like as an open source project, or is that for your company or whatnot? Can you share more, or is it, or are you under NDA? Let's run this guy. Let's quickly skim through this. Evaluate.py. You're under NDA. Got it. Which company do you work for, by the way, if that's not a secret? Just curious. Let's go to README. By the way, the chat will not be in the live stream, so nobody will see what you said nor who you are. 20B, eval tasks, preview queue, and Pika. Let's grab the checkpoint we're training and just evaluate it on on some of these evals. Your configs, eval task, S1. Okay, that's kind of the abstract notion of it. And then here is the actual practical one. So let's just take this. Where are we dumping the checkpoints? That's going to be interesting to see whether we already have stored some of the checkpoints. Let's go to launch. And which framework also do you use to train those large language models? Do you have some internal framework, or are you using some of the public ones, or did you fork some of the public ones? Just curious to learn more. Generation train, okay. Eval. Let's use some smaller one here, like 125M. Otherwise, we'll crash my system because I'm already running the 1.3 billion training. Local setup, eval tasks. Let's put these two here. I assume we have to separate them by like this, maybe not, maybe it should be a single list. Not sure. So that's the eval config. We can now quickly skim through the evals. Looking good. Let's try and run this. So let's go to DeepSpeed, which is the entry script. Let's run the eval config. Okay, let's kick this off. Okay, let's see whether the arguments we passed were correct, or we need to maybe pass a list of those tasks as a single string. It looks like it's fine. And then we'll be running weights and biases as well. Let's go to eval. Let's put a breakpoint there. Let's go to DeepSpeed. Hit F5. Okay. Let me just see whether I changed, whether I've changed the config to use different model parallel setting. No, it's 1.1. That's fine. And again, just to double check so that we don't crash the other run, just double check we are using 125M. We are. Looking good there. Let's go back. Okay. Set up for inference or eval. Let me just see what's the state. $22 gigabytes and 20. We might be close to reaching a CUDA out of memory exception. Let's see whether this crashes everything. The server socket has failed. Failed to bind, address already in use. Okay, so we can't train, we can't, aha. So DeepSpeed is complaining because we are already running the other training. Can't we just use a different TCP address? Can we just set a setting here? Let's see whether we can set that up somewhere. NCCL local setup. Okay. Well, I think we have to. The training run is blocking me from experimenting, so maybe we can stop it and just see. Let's just see whether we have any checkpoints saved. That's the important bit. If we have any checkpoints saved whatsoever, then we can just stop this run. I don't see any checkpoints. Let's see, let's go to the train script. Pretrain. And where are the checkpoints being saved here? Let's see that. Checkpoint should be saved here. That's not really exciting because this is for the end and beginning of the run. What we actually care about is in the actual train script, train function. So let's see where the checkpoints are here. Okay. Let's stop this guy. Okay. Training log. Let's just modify this guy. Let's add, this is just a list, so we can on the fly modify it. We can do something like this, and then I can stop the run. So we have a list. Let's just append to that list. Let's just do the following. Let's just append this particular iteration number, 1317. And then by doing that, we'll basically, once we come here, okay, we're gonna enter here and we're going to save the checkpoint. Okay. Let's save it. And let's also save this one. And then we can kick off training there. And let's just see the checkpoints. Empty for some reason. Okay, what's going on here? Why is this empty? Why didn't we save the checkpoint correctly? Let's see why it's failing. This is empty. I want to save the checkpoint so that we don't waste the time we used to train the model. And then we can go and step through the eval, and then we are done. We are done with GPT-NeoX. I've previously played with Parsec a little bit, with an LLB model. They additionally support Slurm. I didn't see any Slurm support here. Are we running here? Looks like we are. Let's just wait for that to wrap up, and then it shouldn't take too long because we've already gone through 1300 iterations. Okay, while we were waiting, let me just think a bit more about the plan. Just getting to morning on my side of the world. Hi, Robert. Welcome. We've been playing with GPT-NeoX this morning. Where are you based? I guess east side. Let me just ping a couple of friends, ask them for thoughts on PRSec GPT-NeoX and whether they want to start contributing. Personal communication, I'll have to keep that off the streaming screen. Sorry for that, guys. I would be more than happy to share, but other people have different preferences as well, so gotta respect that. You're in Texas, nice. Yeah, awesome. I haven't been to Texas yet, but looking forward to trying the barbecue once I go there. Really, really looking forward to doing that. FYI, Robert, we are basically just training the 1.3 billion large language model currently in GPT-NeoX just as a dummy run, and I'm waiting for the iteration to finish so that we can save the checkpoint before stopping the run and then stepping through the evaluation code just to get some familiarity with their harness function, Eleutherized harness function, LM harness. Hi, Pujan. Welcome. Hi, Asim. Hi, guys. Okay, let's see what's going on. Why is it unable to load the checkpoint? Interesting, something weird is happening here. Everything is running, but I don't see. Is anything happening here? Why is this not running? Yeah, I'm just gonna stop this. Fuck it. Just gonna stop this and focus on the eval. So let's go to DPy. Again, let me now enable all of the breakpoints. Let's switch to eval. Let's run this. Okay, and then let me just see whether we have eval script. We have the, okay, we can run F5. Set up for inference or eval. We've called the same function when we were playing with the generate. Okay, what's up here? Loss partial, something failed. 0 stage 1 requires an optimizer. Interesting. So let's just stop this. Let's go to configs. Is this guy using 0 stage 1 as well? Okay, got it. We just have to go here and set the 0 stage to 0. Okay, now this should work. We've had to implement the same workaround for generate script. So let's go to DPy, let's rerun it again. Okay, looks like it's working this time. And we're here. Okay, so let's run the run eval harness. Let's see how this function looks like. Forward pass, Megatron training. We have 2 tasks, trivia, Q&A, and pcub. Okay, let's enter. Will it be smart enough to download the data automatically? Hopefully. Local rank 1. Vocab size. It's not parallel. World size is 2. Rank. Tokenize, detokenize. Generate samples from prompt. Okay. So let's finally run the eval. So here are the tasks. Number of few shots 0. Iterations. Okay. Here we are, run eval. Model training was training, now it's eval. Pattern match. All tasks. There is 266 tasks that they support. Okay. On 2 tasks. barrier. And now this kicks off the second process. Let me just enter here, enter here. Let's just hit F5. Let's hit F5 again. Let's get here. Let's hit F5. And until we get to here. Oh no, wait. Why are you? I hate the fact that we have two processes, and so every time it, let me just rerun this. Let me see where it downloaded anything. Data, eval tasks. Sorry about this. Let's run. Okay. What's going on? Yet again. Okay. I have no idea why this is going on. Let me try again. We probably have to go. This is because of the two processes, by the way. I know that part, but I don't know why it's causing me issues and not allowing me to proceed with the second process. Come on, let's go. Let's go. Let's go step by step. No pun intended. Okay, let's move this one. This never happened before. Usually I can just skip over all of this. Let me just try and kill one of these. Maybe that will work. Okay. Will that work? If I kill a sub-process, will it be blocked indefinitely? Okay. Not sure. One more attempt. Okay, here are both of the processes. Let's see how this looks like. We now advance the second process to here. And then, so here are, both of them are here. So now if I do this and then switch to the second one. Okay. Almost. Why did it not work? Maybe I have to go through the initialized through this before running the barrier. Why can't it be smart enough? It's not working. Final attempt. Let's go. Okay, and the second one, let's go. Why is the other process running? What is it? What is there to run here? There is nothing to run here. Why are you so annoying? Okay. Can I run this guy? Nah, I'm just gonna kill the whole VS Code. I think it's just VS Code. Okay. Press start. Running the evaluation in GPT-NeoX for those of you who just joined. Okay, let's go. This is the first one. Let's move this one. Okay, found tasks. And then this guy. Found tasks. Thank you, Abhinav. Thanks a lot. Why is this? This is some hack. First get task dictionary on local main rank. The tasks are downloaded as they are initialized. And the downloads don't like multi-threading. So we downloaded them once on the local main rank. Wait and then initialize them on all other ranks, which should load from the cache. So this might be the issue. Let's try. I have one more idea. Okay, so let's just try and step into this. Let's try and step into this before, and then I'm just gonna hit F5 to skip over the barrier. I think that's how we should do it. Okay, let's go to DeepI again. I'm gonna run this. Okay, hit F5. Okay, so let's go here. Let's enter here. So, get the task. No, something's not okay here. Why is this now running? It should not run. It was not a blocking call. Okay. Snap. Let me just see. I'm gonna set a breakpoint here. Disable everything and just put this one here. And now let's rerun it. Okay. Found the tasks. Running the harness. Let me just see whether maybe some cache thing happened in the meanwhile. So let me just navigate to one of these scripts, like copy path here. Why is this so minified? Let's just navigate here. Let's see the status here. So we modified the YAMLs, that's fine. We have data, playground, TX, so everything that I downloaded is here. And nothing smart happening there. Maybe I messed up the cache by stopping the script the last time. I'm gonna disable all scripts. Let's just disable everything and let's just run the dpy with the eval config. Let's see whether that's gonna make it past that line that we get stuck at every single time. It looks like we get stuck there every time. Why is that? This is basically not working. Let me see whether maybe somebody had a similar issue before. This is just a training run from the 1.3 billion parameter model that we ran as a test to just play with GPT-NeoX for those of you who just came. Let's see whether okay. It's basically running, but nothing's really happening. Maybe, just maybe, we shouldn't pass the local config. This guy here, local setup. Let me go to the README again. Let's run without the local setup. What will happen then? If we go to launch JSON and if we remove the local setup config here and just paste these two eval tasks, what will happen? Evaluate. Let's see. Or maybe we need to change the task because something is messed up with the cache. See. Okay, this now fails because we don't have the tokenizer. So that's not the solution. The solution might be to change the tasks. Pika, is there any other task we could run? Maybe Lambada and let's just run Hellaswag or something like that. Hellaswag. Okay. Let's rerun. Okay, it's finally running. There was some caching issue probably. Let's let it download the dataset if it's not too big. Hellaswag dataset size. 68 megabytes. Around 100 megabytes it says here. It seems it's working here. So once it's working, we can just start stepping through the actual code. Running log likelihood requests. Let's see. Okay, what's going on here? Okay, here it is. I can hear the sound of the GPU working. Yeah, there was definitely some caching issue with the previous tasks because I ran, it got to this point and then I interrupted it, and so maybe some corrupt. So we can just try this same dataset again and step through the code, or we can take yet another dataset just to see the whole process of downloading data as we go, as we are stepping through the code base. How can someone without GPU pursue this? When you say pursue, you mean like if you want to train machine learning models, you have to have a GPU. But you can get a free you can sign up for some cloud, and the first 3 months you get some free GPUs and Colab as well. I made a video a couple of years ago on this topic. You can check it out on my YouTube channel. Okay, this is almost done. And then it failed. One process exited successfully, but the second one failed. Why? Attempted to change value of iteration from none to 0. If you really want to do this, pass allow val change to config update. What's this? Nobody has been hitting that issue. Okay. No insights there. Keeps on crashing. Let's see what's the issue there. So we managed to run the eval and then something failed at the end. This one process exited successfully and the second one had some issues. with configs, but like I don't think the core logic was, this is just at the end of the script. So we can, I think we can now rerun this and step through the script. So let me open up the evaluation. Let me add a breakpoint there and let's rerun this. Okay. Okay. So far, so good. Let's advance the other process. Okay, they're both here. Is local main true? Let's see what happens here. Okay. And this one now exited. This looks good. Okay, we couldn't, this is a progress because previously we couldn't do this. It would just get blocked. So now we can actually run this. So let's see, task name from object, task name, Hella Swag. Okay, we have some dictionary, Hella Swag as the key, and then probably the data class, the class that's handling the download and everything, processing is there. Some assert, and then we return back that value, and then okay, we are here. Nice, awesome. Let's go and let's dig deeper into this function here. Okay, here we are. Evaluate the model on the list of tasks. I think by the end of this stream, we'll have gone through the GPT-NeoX, and then we can start thinking about how to start training the models and collecting data. If we ever run into issues where the eval tasks don't fit in memory and we can't afford a machine with bigger memory, we can always modify this plumbing to support that, but I didn't want to include it just yet because over-engineering is bad. We could make it write the request to disks and then read them back out again, probably using an SQLite DB because of all the moving parts we have. Okay. Validation docs. Let's get here. Shuffle. Description is empty. And then okay. Task docs. Okay. Where did we do this already? Task docs. Aha. Probably this function automatically does the download, but we've already done that for HelaSwag, so we are skipping that right now. So okay, let's see. Here is the task. So this is HelaSwag, I guess. We have a query, personal care and style, how to increase breast size with a bra. Check your bra size. Wearing a bra that is too big will not make your breasts look larger. I'm gonna get banned from the stream. That is why it is important to wear the right size bra for you. Okay, and then there are some choices. Let's print out the choices. Let's gonna print out this whole thing. There is a query. Let's see what the keys we have here are. So we have doc, and then there is the choices of 0. You can visit a lingerie shop and then have them measure you to help you fit a bra to your size, or measure yourself before you shop, blah, blah, blah. Choice 2. And choice 3. And then there is a gold. Let's just print out the gold. Okay, gold is 0. So the 0th answer, this is multi-question, multi-answer type of a task. If should decontaminate, view shot content. Again, this is inside of LM eval. Let me see, where do we enter LM eval? We enter from exactly here. So the evaluator evaluate is delegating this to the LM harness. Okay. So task few shot context. Here's a document. Here's the number of few shots. And that's going to be because we have 0 here. We are going to do this 0 shot. Let's see where we can enter here. Okay. Doc to text. Returns the query. And then takes the description, which is empty, labeled an example. Okay. And that's the context. And then we say construct, given the context and the document, we construct the requests by doing what? For choice in choices, we format, and then we call the RF log likelihood. What is RF? What's going on here? Not sure what's going on here. Okay, so it just creates a request. So let's basically multiple choice task. This is a particular, okay, that makes sense. Let's see the 0th value of this list. Okay, request log likelihood, personal care and style. Okay. And then we retrieve that, and then for all of the requests, we append requests here, and then some more appending. So we're preparing the tasks basically here. Let's just put a breakpoint here, hit F5. Running log likelihood requests, get the attribute, from LM, Is this gonna actually call? What exactly is the aim? The aim is to just get a bit comfortable with the code base, because we'll probably be implementing code here in this repo, because many people are familiar training larger scale models in GPT-NeoX, and it might be easier for the community to basically contribute if we use it. So that's kind of the idea. The thing with Faircheck that I don't like is the NLLB branch is like 1 year old, and I'm not sure. We're still thinking what's the best option going forward. Okay, this is actually running the LLM in the background. No worries. Basically just warming up some muscles, getting familiar with a couple of these code bases so we can make educated decision. What are the pros and cons of both of these frameworks? What makes sense? Okay, it's running now. We should have stepped into this. Let me stop everything. Let me disable all breakpoints except for this one. And let's again rerun this. We want to enter that just to see what's going on there. To see what's the design for eval. Okay, let's do F11 here. Let's just enter something is not okay here. It's stuck. Rect type not defined. LM not defined. What's going on? Pause on a breakpoint. And this one. Okay. Why is this blinking now? What's up here? Let me just stop here and then I can extract manually and put a breakpoint directly there. So again, let me run this. Okay. So, request type log likelihood, LM, get the attribute. So this is going to be what? Bound method base lm log likelihood of the adapter object. Okay. So if we go here, let's see. I'm fairly sure that's the function that we'll be executing. Okay, let's go back here. Hopefully we hit some of the breakpoints in the adapter. If not, then we can just ignore it for now. Don't want to lose any more time doing this. Okay, so we are hitting the log likelihood tokens in the eval harness adapter, inference mode. Okay, and then requests. There is a ton of requests here, 40,000 requests. And then what we do is we call collate function, which basically takes the request and then grabs the x1. Okay, let's see this. If we grab the 0th element, and then what's the type of this object? Is this a tuple? Looks like a tuple, okay. And then what's the length? 3. So request 0. 1 is just tokenized some tokens and the original text. Okay, so what does it mean for this function to collate x of 1 and x of 2? Okay, probably just these tokens here. Makes sense. Here is the input length, actual input. We just pad with zeros, and then we add it to the inputs. Okay, we can just go here, and then we go call the model, TP scatter. What's the shape of the inputs? 8151. Scattering. Forward step goes here. Are we model eval batch? Return logits. is what? True data iterator. We're now in DeepSpeed again. Okay, so let's just ignore DeepSpeed for the time being. And now we kick off the second process here. So we can just hit F5 here, model call, TP scatter. We can ignore all of that. And then eval batch. We can ignore that as well. And we are back here. So we do just the gathering of logits across devices, I guess, and then all gather. Okay. Return the logits. Softmax. On squeeze. Blah, blah, blah. And then we get to the actual answer. And append the answer. Okay. Let's just remove these breakpoints. Let it run. So it's now running. It's going through that loop, basically running the inference, getting the logits, calculating the answer. That's how the eval looks like. Okay, very nice design. I like it. Thanks, Abhinav. See you later. Are you in the Discord server, by the way? Do join the server there. I'll be posting updates to the, let me just change this to the server. I'll be posting updates to this channel here. I have to change the thumbnail to 4 here. This is day 4. Yeah, just check it out. I'll be posting everything I'm gonna do over the next days. I'm going to Shanghai, China, on 18th of September, some business trip. Basically, Huawei folks invited me to join some event, and so I'll be going there just for some event. And until then, I'm planning to stream every single day and to get this project up and running. I'll probably be working there as well. Hi, Tenmei. Welcome, man. Okay, we are almost done. Okay, here we are. So this loop is now over. We can skip. We have the results. Get original. What's this? Okay. Return. Let's go back here. So we have the responses. Awesome, thanks. Yeah, it's almost, well, 20 days. In 20 days, I'll be there. Process the result queue. Okay, so this is just a dictionary, default dictionary of, we just append some stuff here, and then we can hit F5 to get here. Process results, documents, gold, and requests. So this is gonna do the actual evaluation. So here's the gold label. And I'm fairly sure we'll end up with 0 accuracy just because basically we are using dummy checkpoint metrics. Okay, as you can see, most of them are just 0. Calculating a standard error. Okay. And then let's go back here. Let's remove this. Results, accuracy 0.25%, which corresponds because I think, do we have 4 answers per query? So in that case, this is just random performance, right? As expected, because we're using a random checkpoint. And we're done there. So now we just pack the results. And we go back here. And we're done. So now there's just some logging, so I'm going to stop the program here. Okay. I'm just curious to see the implementation of the task, and that's going to be the last thing for this stream. Okay, we can stop all of this. We can stop. Okay. Let's just pick some random task and see how the download, how that whole thing works, how the setup is, how the task is set up. And then we can wrap up this stream. And in the next one, we can already start coding something, playing with data. We're gonna see what's the best thing to do next. Okay, so let me go to README. Let me open up the readable version, the human readable version, and then let's go Hella Swag. Lambada. How big is Lambada as a data set? Lambada size. $300 megabytes, maybe. Okay, so let's pick Lambada. Okay, and this time let's focus on understanding how the task download and processing works. That's something that interests me here. Let's put some breakpoints so that we don't download before I understand what's going on. I was about to sneeze. Okay, here we are. Again, let's just jump here. Run eval. Okay. Found tasks 0. Huh, interesting. Why not? All tasks. Huh. Okay, Lambada is not here. Why? Let's see more of these. Interesting. Then let's just grab whatever. We can grab Vino Grande. Disable everything except for this. Where is the DPy? Here it is. Let's run it. How did you guys find the live, by the way? Through Discord, or you got notification on my YouTube channel? Please let me know in the chat so I can invite more people later to join. Okay, here we are. Is this gonna be the first time somebody built a large language model while streaming the whole process? That's gonna be fun. Fun experiment. Okay, here is the... You follow me on LinkedIn. But how did you find this particular live today? I guess that's what I was curious about. Okay. Why is it... How is this downloading data? Where? Oh my god, okay. Get task, and then they actually call it right here. Got it. Thanks guys, thanks Asim. Robert saw it in the Discord, makes sense. From YouTube homepage, I saw you were live on YouTube. Okay. YouTube recommended. Oh, nice. That's cool. Thanks, guys. Thanks for letting me know. Okay, we are screwed because again, we need a breakpoint here. I want to analyze what's going on in this get task method. That's where the magic is happening that I'm curious about. So I'm going to stop this again and just use some random different data set. Like again, there was Lambada. There's this. Let me just make sure it's not huge data set. Probably it's not. SciQ data set size. Okay, 13,000 examples. That can't be too big. So let's use that one. Oops. Put it here. I actually followed your day one stream from LinkedIn, but couldn't complete the day one. Was trying to pick up from where I left and found that you were streaming right now. Okay. Thanks. Ayohit, if I'm pronouncing your name correctly. Save. Let's rerun. Let's just make sure that we have the correct breakpoints in correct places. Running DeepI. We're wrapping up this stream soon, in maybe 15-ish minutes. We'll see. I see there is more viewers now than yesterday. I guess, well, Sunday. Guys, Sunday is the best time to work. You don't believe me, but it's true. Okay, let's go here. Let's enter. So, get task. That one is going to fetch the task, and then we're going to execute immediately. So let's see, task registry. Task registry, and our name, we are looking for SciQ, I guess. So lm eval tasks SciQ. Okay, let's see how we can find that one. We'll probably just have to, let me just F11 into this. Okay, so here we are. So we are now in LMEval package inside of the task class abstraction, and then we first do download. Okay, there is nothing specified here, so I'm not sure where this is gonna download the stuff. So let's see. So load the dataset. Path is SciQ. Where is this getting downloaded to? I'm not sure. Maybe root. Nope, I don't see the previous. I don't see, maybe temporary directory or something, who knows. It's highly likely just a temporary directory. Okay, so this is now datasets class from I guess Hugging Face folks. But what are we even downloading? Okay, IQ makes sense. And then we call, okay, let's just execute this. Okay, thanks for the tip. Let me quickly check what the value is. I guess it's defined. Is it defined here? How can we just do OS? I don't think it's defined here. Let's see. Okay, we don't have to get into Hugging Face. That's not the point. Let's hit F5. Okay. So all of this comes from Hugging Face, apparently. So we go back here. We go back here and we end up with okay, with a task. Okay. I'm just gonna open up quickly the LM. Just curious to see how this looks like. Okay. Doc query. Gold. Process. Multiple choice task. LMEval base. Let's go to there. Okay. I think we're done, guys. Let me just kick this off so it can complete. I'm gonna wrap up the stream for now, and I'm gonna make a short plan in the break. I have a small lunch break, and then I'll be continuing 3:30 p.m. So that means in 40 minutes, I'm gonna make some plan for what to do in the next stream, and I will let you know in the Discord channel. So again, these stupid errors with configs, we can ignore all of this. And we're uploading some stuff to weights and biases. We can ignore this. Just ignore the crashes. That's fine. Awesome, guys. See you a bit later. Have a nice day. Have a nice evening wherever you are. Bye, guys.